Welcome back. In our session, we have, I think you enjoyed your break, isn't it? Yes, very nice. Now, this is still tutor.com. Tutor.com. Don't forget to rate our lesson, also to comment about the lesson. How did the session go? Yes, now we stopped on the colors of cations. I was going to show you how do colors come about. And by the way, which colors are we talking about? So can we go there? Remember at the introduction I told you that the colors we are going to talk about as one of the lesson objectives is the colors of cations. How do cations show colors? Let's go. Now, the first color is what we call blue. You people have mixed a lot of colors. I like, by the way, mixing the colors as well. Now, you know blue color, do you? Yes. Now, the blue color which you see in the lab is due to one of the transition cations which we call copper 2. We call it what? Copper 2. Good. This is what we call copper 2. So whenever you see blue, by the way, I'm going to show you blue. This is the blue color we are talking about. Look at it very carefully. This is the blue color. Can your eyes see it? Yes. Whenever you see it in the lab, it is due to the presence of what we call copper 2 ions in that solid. By the way, when you dissolve it in water, it will tend to dissolve, or it may not dissolve. That's why we are going to solubility rules immediately after this. So wait for that great session there. Then number 2 is the green color in the laboratory. Whenever you look at a green color in the laboratory, you have to get to know that green color means a lot of cations in the laboratory. One of them is what we call iron 2 ions. Another one is what we call copper 2 ions. Copper 2 has come back again. So copper 2 has got what we call the green color and the blue color. Now you can ask yourself why. Some of the salts of copper are green in color when others are also blue in color. That's why it has got 2 colors. Now in addition to that, we have also got what we call nickel 2 ions. These ones are purely green in the chemistry laboratory. Yes, in addition to that, we have got what we call chromium 3. Chromium 3. Remember, chromium has got very many ions. But specifically, we are looking at chromium 3 to be the green one. Good. It is here. Now, can I also show you the green color I'm talking about here in the chemistry laboratory? Very nice. It is here. This is the green color. Can you see it very clearly? Very nice. This is the green color we are talking about in the chemistry laboratory. Yes. In addition to the green color, we have also got to move on with another color in the chemistry laboratory, isn't it? Yes, good. This is the brown color. The brown color in the laboratory, in most cases, it is due to iron 3 ions. Iron 3 ions. But you people, you remember the oxidation of iron 2. You remember the oxidation of iron 2. Now, iron 2 is also tending to be brown on early oxidation. So don't reach in the laboratory and you see brown and you only think about iron 3. This one can also happen. Iron 2 can also happen. Don't forget that. So iron 2 and iron 3 can be 2 of the cations which can seem to be having a brown color. Let me show you the brown color before I forget. Yes, our brown color is right here. This is the brown color which may be containing either iron 3 or iron 2. We are going to explain more about that. There is a lot of chemistry to discover here. Very nice. You people, the colors are almost getting closer to the end. Allow me to take you to another unique color, which is called pink. You may not have discovered it in an ordinary level, but here we have got what we call pink color in the chemistry laboratory. Allow me show you the only pink color due to the presence of manganese 2 ions. Manganese 2 ions. Very good. Yes, manganese 2 ions. I have got to show you this color here. So it is here. Look at it clearly. Yes, the color is even laughing. You can see. Yes, that is very interesting. It is very interesting. We have got to move on. Now, you know that whenever you see a pink color in the laboratory, your first thinking should be, it could be one of the transition cations, which we call manganese to ions. Manganese to ions. Very nice. Now, lastly, we have got what we call white cations. We have what we call white cations. When you look at these white cations here, the white cations, there are very many of them now in the chemistry laboratory. One of them is zinc. It is zinc. The second one is what we call aluminium. Aluminium, yes. We have got what we call lead 2. Lead 2. You see, somewhere I will say a 2. Somewhere I don't mention a 3 or something. Because of the presence of many valences, these compounds or these ions do contain. Now, I have got lead 2 ions. I have got barium ions. Now, barium I have not mentioned there too. Yes, you know the reason now. Barium ions. We have got what we call calcium ions. All these ions here are white in color. But remember, when we dissolve them in water, they will become colorless. Don't forget that. We shall reach there on solubility. Then another one we have got is what we call magnesium. Please differentiate between magnesium and manganese, which was pink in color. Don't forget that. I have got the only cation which smells like urine in the chemistry laboratory, and that is ammonium ion. I think you cannot forget that. Yes. Then another one is tin 2, and lastly is tin 4. All these ones, among very many of them that we are going to discover here in qualitative analysis of inorganic chemistry, is what we call tin 2, tin 4, ammonium, magnesium, zinc, aluminium, lead 2, barium, and calcium. All these have got a unique color which is called white. Now, allow me show you the white color. Allow me show you the white color. This white color might be a powder, or it might be a crystal. So they can be powders or they can be crystals. Even these ones which we talked about, all of them, they can be powders or they can be crystals. Please don't forget that. So I am going to show you the white color. Allow me show you the white color. Here it is. Here it is. When you look at it very carefully, here I have used a filter paper where I have placed it. This is what we call a white color. White color. Very good. Yes. Now you people have got to understand the colors of cations. The colors of cations. The colors of cations. One of them was blue, another one was green, another one was brown, another one was pink, and another one was white. Isn't it interesting? Yes, good. Now, we are going to move on to another important concept, which we are going to call the solubility rules. Don't forget to rate our lesson. Don't forget to comment in the comment box, such that we can also see what is exactly happening. Don't forget that. Yes. Now, solubility rules. When we talk about solubility rules, we are going to talk about if I get all these solids which I have given you and I dissolve them in water, what do you think will happen when I dissolve them in water? What will be their colors in solution form? Or if they don't dissolve in water, what would be the reason? We are going to look at what we call solubility rules. Solubility rules, very good. Now, different from ordinary level, we are going to advance our solubility rules by adding some of the anions. Some of the anions. By the way, the reason why we are going to dissolve these and we see different colors and different changes in solubility, it is because of anions. Remember, the other one was due to, the colors were due to cations. But this time around, the dissolving in water will be due to the anions. Due to the what? Anions. Allow me to take you through the solubility rules of these anions which I talked about before. Yes, don't forget we are going to have our break after some time. Yes. So prepare what you will be, how you will be jogging and so on and so forth. Now, the solubility rules. We have got the first one, and the first one is all nitrates are soluble. All nitrates are what? Are soluble. When I get any salt, let it be pink in color, let it be blue in color, let it be green in color, let it be white in color. When I dissolve it in water, as long as it is a nitrate, it will dissolve in water completely to form a solution. Therefore, I will not be having any solid particles inside my solution. That is the first solubility rule. What do we make in deductions? We are going to see that. Remember I told you that a deduction in chemistry means a conclusion which you make. A conclusion which you make. We shall get to understand that. Yes. Then we have got also what we call the second solubility rule is about ethanoates. We say that all ethanoates are also soluble. All ethanoates are what? Are soluble. Very good. It means different from this. We have also what we call ethanoates, which are also soluble. So in the lab, when you see a substance dissolving completely, don't think about nitrates only. You have also got to think about ethanoates. Can you? Yes, good. So we have another solubility rule, which is rule number 3. Remember I told you we are going to differentiate between a sulfate and a sulfate. Now, rule number 3 says all sulfites are soluble except, now these are sulfites different from sulfates. Now, sulfites with I are soluble. They can also dissolve in water to make solutions. Except we have got lead 2 ions. When we have lead 2 sulfate will not dissolve in water. We have got what we call calcium sulfate. Calcium sulfate will also not dissolve in water. We have got what we call barium sulfate. Now, these 3 here do not dissolve in water. I like you people who know the combination which we call PCB in A level. Now, you can simply say all sulfates are soluble except PCB, where PCB is lead, barium, and then calcium, or you can say lead, calcium, and barium. That is PCB, which I am talking about. So all sulfates can be able to dissolve except PCB. I've got to take you back to what we call now the sulfates. Sulfates. Now, all sulfates are soluble. All sulfates can also dissolve in water. But we have an exception also. Don't forget the exception. The exception is still PCB. But lead 2 sulfate, barium sulfate, and calcium sulfate, these 3 are also insoluble. However, calcium sulfate, which I have just underlined here, it is sparingly soluble. It is sparingly soluble. Yes, when we go back to our physical chemistry, we shall explain what the meaning of sparingly soluble. We shall get to understand this. So you need to know the difference between sulfites and sulfates. How do they dissolve in water? All of them dissolve in water, apart from PCB, but for a sulfate, calcium sulfate, tends to dissolve. However, it is sparingly soluble. But when you come to sulfates, calcium sulfate is completely insoluble. It does not dissolve in water. Yes, so that is the difference between the two, a sulfate and a sulfate. Let's go to what we call the carbonates. The carbonates, which in most cases are in powder form in our laboratory. We shall get there. As we reach on heating, yes. Now let's move. all carbonates except potassium carbonate, sodium carbonate. Those are 2 now. Ammonium carbonate, they are now how many? They are 3. Those 3 are soluble in water. However, the rest of the carbonates are purely insoluble in water. They don't dissolve. You will try to dissolve it 1,000 times. It will refuse to dissolve in water. Therefore, we call them insoluble. We say all sulfates are insoluble. I mean, all carbonates are insoluble. So get to remember that one. So examples have been given: sodium carbonate, we have got ammonium carbonate, and then we have got potassium carbonate. These 3 are soluble, but the rest are insoluble. Then the second last one, someone can say, why is it not the last one? But it is the second last one. Remember, I did not talk about hydrogen carbonates. Now, we have got what we call all chlorides. All chlorides which you know. Mention them. Can you mention examples of chlorides? Yes, that is 1. Number 2? Yes. Number 3? Very good. Now, you can continue mentioning as many as you can. Very nice. Now, we have got one of them which we call lead 2 chloride. We have got another one called silver chloride. We have got another one called copper 1 chloride. This time round, not copper 2 chloride, my friend. Oh, my friends. All of you, you're not there. Now, copper 2 chloride, copper 1 chloride, is one of the chlorides which cannot dissolve. Which cannot dissolve. You got it. Very nice. Which cannot dissolve. Now, all chlorides are soluble in water. All of them can dissolve in water, except lead 2 chloride, silver chloride, and copper 1 chloride. But remember, lead 2 chloride is very, very stubborn. The moment you warm and the water starts to warm up, you will see the lead 2 chloride, which had refused to dissolve in cold water, has dissolved in warm water. Therefore, lead 2 chloride is soluble on warming. We have this, and we have used it many times, by the way. We have used it many times. Yes. Now, the last one, as we warm up for break. Don't you like break? Yes, that is nice. As we warm up for break, we have got what we call hydrogen carbonates. Hydrogen carbonates. Now, all hydrogen carbonates which we have are also soluble. They are also soluble. These solubility rules here, we are going to apply them whenever we are making conclusions, when we have dissolved a solid in water to make a solution, or when it refuses to make a solution. Now, our next session, as we prepare for break, be thinking about this has been solubility in water. Be thinking, how do they dissolve in sodium hydroxide solution? How do they dissolve in ammonia solution? You can have a good break. Enjoy your break.